Hi, welcome back to Mr. Chemistry. This is Charles Gas Law lesson number 4. Okay, again, our flow chart is 1 ATM equals 760 millimeters of mercury, 760 torr, 101.325 kilopascals, 101,325 pascals, 1.013 bar, and 14.7 psi. Standard temperature and pressure, which is often referred to, it would be at 0 degrees Celsius and 1 atmosphere. 1 millimeter of mercury equals 1 torr. K equals C plus 273. And remember that 1 milliliter equals 1 cubic centimeter. Charles' law is known as V1 over T1 equals V2 over T2, but more easily put, V1 T2 equals V2 T1. And pressure is the constant under Charles' law. Okay, let's go ahead and do this. So let's see, it has an initial temperature of 50 degrees Celsius. The temperature becomes minus 5 degrees Celsius. Okay. And the volume becomes 212 centimeter cubed, which is the same thing as 212 milliliters. What was the initial volume? Okay, first things first, we have to convert our temperature. So K equals 50 plus 273.15. So our T1 temperature in Kelvin is going to equal 50 plus 273. So we go 50 plus 273.15. And that's going to equal 323.15 K. All right, now I have to look at my second T temperature. So that's what I'm going to do right now. And let's go ahead and take care of that first. So our T2 is going to equal the following. It's going to be negative 5 plus 273.15. So T2 is going to equal 268.15 looks like. So it'd be minus 5 plus 273.15. That's right, 268.15 K. Much better. 268.15 K. All right, now I'm ready to solve. So I want to solve for V1. So V1 equals V2 T1 over T2. So I just throw in my numbers, right? So V2 is, of course, 212 milliliters, because I'm not going to call it cubic centimeters. I could, but I'm not going to. And then, of course, our T1 temperature is 323.15 K divided by our T2 temperature, which is going to be 268.15, and that'll be K. So my K's cancel out, and my V1 is going to equal, let's see here, 212 times 323.15 divided by, okay, let's do that, times 323.15, right, divided by 268.15, and my new volume is going to be 255.48 liters. 255.48 liters. Per milliliters, actually. Sorry about that, milliliters. Okay, let's look at our second one. At 210 degrees Celsius, a gas has a volume of 10.5 liters. What was the new volume if the temperature is lowered to minus 100 Celsius? So T2 is going to be a negative 100 Celsius. T1 is 210 degrees Celsius. Its initial volume is 10.5 liters, and we're looking for our second volume. Well, the first thing we have to do, of course, is convert our T1, T2 temperatures. Okay, and to do that, remember that K equals, and then we're going to do the first 210 one first. It says 210.0 plus 273.15. So T1 is going to equal 483.15 K. T2 is going to equal 173.15 K, because think about this, 273 173.15 minus 100 is going to be 173.15. So now let's isolate for our V2. So V2 equals V1 T2 over T1. So V2 equals 10.5 liters times our T2 temperature, which is 173.15 K, divided by our T1 temperature, which is 483.15 K. Of course, the K's cancel out. And now we'll get our new volume. We just got to do the math. So we take 10.5 times 173.15, okay, divided by 483.15, and that's going to give us 483.15 liters. Don't like that. Let's see, let's look at this again. Our initial volume is 10.5 liters, and our T2 temperature is 173.15. Right. So let's go 10.5 times 173.15. Got it. Divided by 483.15. That's better. Yeah, something wrong with the calculator. 3.76 liters. And that's our answer. Well, listen, you guys be snarly, and we'll see you back here at Musin Chemistry.